Welcome to Chapter 3 of our Algebra course hosted by Iridium Tutoring. Chapter 3 is based on systems of equations. This video, we will be going over a very brief introduction to systems of equations. Introduction to systems of equations. A system of equations is when we have multiple equations and we solve for the values that satisfy both equation. Here's an example. We have the equation x plus y equal 2, and we have the equation x minus y equals 0. So let me just write them like this for simplicity. We can clearly see that when x is equal to 1 and y is equal to 1, they both satisfy the equations above. This is what we call the solution to a system of equations. We will look at systems of equations from a graphical approach first in our next video. So going back to these two equations right here, x plus y equals 2 and x minus y equals 0. So if you look back here, x equals 1 and y equals 1. Let's take this equation. If x and y both equals 1, then 1 plus 1 equals 2, meaning 2 equals 2, which is correct. So let's put a check mark. And then same for here, 1 minus 1 equals 0. So 0 equals 0, which is true. So both equations are satisfied by x equals 1 and y equals 1. Graphing systems of equations. We'll be dealing with systems of equations in two variables, x and y, but know that they can be made in any amount of variables. Example, find the solution to this system of equations. Y equals 3x plus 2 and y equals negative x. You can find the solution by figuring out the point of intersection of all the equations provided. Meaning you have to plot this line, and then the solution is the exact point where they intersect the two lines. In this case, the intersection is at negative 0.5, negative 0.5. This means that when x equals negative 0.5 and y equals negative 0.5, both equations are satisfied. If you look at this graph, the green line is represented by the equation y equals negative x, and the red line is represented by the equation y equals 3x plus 2. And when you draw those lines out, this point right here is the point of intersection, and that point is at negative 0.5 comma negative 0.5. And if you remember, points are plotted as x comma y. This is why you would say the solution is x equals negative 0.5 and y equals negative 0.5. Solving systems of equations algebraically. Although you can graph systems of equations to solve for the solution, you can also solve them algebraically. Example, the substitution method. The substitution method solves for variables by substituting one equation into another equation. One variable will be able to be solved, and that value can be plugged into an original equation to find the other variable. We will be talking a lot more about the substitution method in our next couple of videos. And next is the elimination method. The elimination method solves for variables by performing addition or subtractions of the respective equations to cancel one of the variable out so that only one variable is present. From there, we can solve for that one variable and then plug in that value into the original equation to solve for the other variable. We'll be talking more about the elimination method in the next videos. These are a couple of examples of special solutions. First, there is no solution. A system of equations will have no solutions if you end up with an equation that will never be true. An example of this is 3 equals 0. 3 cannot equal 0, 0 cannot equal 3, hence there will be no solution. Geometrically, this will look like parallel lines because they will never intersect, leaving us with no solution. Remember, with two equations, they need to intersect to have a solution. But the definition of parallel lines suggests that they never intersect. Case 2, infinite solution, or all real numbers. A system of equations will have an infinite solution if you end up with an equation that will always be true. An example of this is 9 equals 9. Geometrically, this will look like the lines are in the exact same position, sharing all their points. So you'll see them as one line, but know that they're actually two lines on top of each other. That's why they have infinite solutions, because they're the same lines. A special way to write infinite solutions or all real numbers is with this symbol, which means all real numbers. Apologize for my bad handwriting. And then usually the previous case we talked about, no solution, is represented by a 0 with a slash going through it. That is it for this video. I hope you enjoyed the brief introduction to systems of equations. Please stick around for our next videos on systems of equations, and I'll see you next time. Bye.